We're going to continue today and wrap up our study on graphing inequalities. I'll work one more problem for you. We're going to sketch the graph of the linear inequality 5x, let me get this in the screen here, 5x plus 4y is less than or equal to 12. Let's start by solving this inequality for y. So we'd get rid of this 5x on this side of the inequality sign by subtracting 5x here, and we'll subtract 5x on this side. So this is going to become 0, and we're going to have 4y is less than 12 minus 5x. Now we can go ahead and divide by 4, and we'd have y is less than 12 divided by 4 minus 5 divided by 4 times x, which is y is less than or equal to 3 minus 5/4 x, and we can move these around and we get y is less than or equal to a minus 5/4 x plus 3. Now if this is an equal sign, this would become y equals a minus 5/4 x plus 3, and this is the boundary of the inequality. It's the equation that generates the boundary of the inequality, and let's work with that first. We'll find that boundary, plot it, and then we'll determine what side the inequality is on. Now, notice that the inequality is a less than or equal to inequality, so this boundary line will be a solid line because the points on the solid line are part of the inequality because the inequality is less than and equal to. So let's go ahead and plot this, and we can plot this. We know the slope and we know the intercept. The slope is a negative 5/4. The y-intercept is 3. So here's our graph, our coordinate system. This is x. This is y. This is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5. This is a minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. Okay. Our equation was y equals minus 5/4 x plus 3. So our slope equals minus 5/4. That's the change in y divided by the change in x. And our y-intercept is a positive 3. So we know that this, the y-intercept, positive 3, is a point on our boundary line. We know the boundary line is a solid line because y is less than or equal to 12 minus 5x. So this less than or equal to tells us it's a solid line. Now we just need the slope. Well, we can go down 5 and a positive 4, or we can go up 5 and a negative 4. So let's do it both. If we make our y negative, we'd go down 5 units. So here's 1, 2, 3, 4, 5, and we'd go to the right 4 units. 1, 2, 3, 4. So this would be a point on the boundary line. Or we can go positive 5 in the y and a negative 4 in the x. So we'd go up 5. Well, here's 1, 2, 3, 4, 5. So that would give us, here's, okay, 1, 2, 3, 4, 5. And then 4 in the negative would be right up here. Okay, this point right here. So we can connect all those points. And we should get a straight line. It's a little crooked for some reason. But that is our boundary line. Now we need to determine what side of the line is our inequality. And let's try it first with the 0, 0. That's usually the easiest one to know. And if we substitute our 0, 0 into our original inequality, and if the inequality makes sense, then we know that the inequality is on this side of the boundary line. If it doesn't make sense, we know the inequality is on the other side of the boundary line. So we'll substitute 0, 0. So I'll do that over here. Y is less than or equal to 12 minus 5x. So 0, 0, y is going to be 0, is less than or equal to 12 minus 5 times 0. So 0 is less than or equal to 12. And that's correct. That's a true statement indicating that our boundary line and the region of our inequality, not unequality, inequality, is on this side of the boundary line. Okay, because when we plug this point in, the inequality made sense, and we got 0 is less than or equal to 12. It's a solid line because every point on the line is part of the inequality. And that's the end of that problem.